The meeting has started at 5:30, and did we want to start with call to order first? So why don't we take attendance as to who is here? I'll start. Kristinaro.
Paul Bohm.
Keith Hannon.
Bruce Curlis.
And Delia King.
Okay, so we're just missing Jeff for the moment.
Yeah.
Okay, so do we want to go to public comments? Does anybody have any public comments that they would like to share before we start?
And I'm letting Jeff into the meeting right now, so.
Okay.
Hi, and this is Bruce Thompson with the Maximus. I just joined.
Hi, Bruce.
Hi, Bruce. Thank you very much. We were just asking if there were any public comments from the public, and doesn't seem like there is any. I don't see any hands raised. So should we just move into should we accept the minutes, or just move into our speakers first and then accept the minutes from our last meeting?
It's up to you all. It can be, we have speakers here, and if we want to hear from them first, we can put the minutes on to be done after that. I think that's fine.
I agree.
Okay, so our first speaker, who was our first speaker then? Is it
Bruce on the telephone.
Bruce? Okay. Bruce Thompson, you are on. Thank you so much for joining us.
Okay, so I'm obviously coming in with a little, probably lacking some of what all you're all doing, but Paul talked to me about the potential that there may be soil excavation from MCI, and is there the potential to utilize that soil as backfill at the Nuclear Metals Inc. site remediation that I manage? And
Bruce,
I think yeah.
Hi, Bruce. I'm sorry. This is Delia. If I can just, I'm sorry to interrupt, but let me just give you a little background so that you have some context. So the Warner's Ponds Task Force was created it was created in February of this year to evaluate options for the future of the pond. And one of the options is dredging. As you know, we had talked about that.
Yep.
Another is dam removal, and the third is, well, there are many other potential alternatives. What we're trying to understand is this is the subgroup for the dredging. And so this group is looking at alternatives to the dredging bid that went out, which you're familiar with because I had provided you with those soil sediments from the pond.
Mm-hmm.
And so what we are now looking at is the possibility of using an unrestricted field on the prison land and excavating that to a variety of different depths. And one understanding that we have is that StarMet needs, there will be, more than 85,000 yards of material that is removed from that site. And so that material in that north field, as we're calling it, it's good uplands, gravelly, sandy, there's some ledge in there, but it's generally decent material. And what we would like to understand is if StarMet is interested in that material, talk us through that in terms of what it would take for you to consider it acceptable, your time frame, and any testing parameters. And there might be others that the group wants to understand.
So, I mean, for our side, we have a pretty formalized set of specifications, depending on whether we're bringing in imported material as, say, topsoil, structural fill, there's a variety of things there. And so just generally the testing is going to be probably both geotechnical, right? The compactability, all, those, grain size, those standard things. And then chemically, we have to meet the cleanup levels at the site. So we don't get to use, any mass state defaults. It's very specific to our cleanup levels. The one that I can tell you from trying to get other imported backfill, we have very, very low PAH, polyaromatic hydrocarbon, acceptance levels right now, like at a quarter part per million. And I think that's probably a significant challenge. And then generally, we have to resample and verify it, on something in order of like 1 every 5,000 yards. If you had a defined area that you knew, basically you wanted gone, we could probably work with EPA to pre-characterize it through, soil borings, and you collect samples from those, and then we could say, this football field by 60 deep, for example, is good, and we could reuse it. So that's we have to go through that with EPA, and I have to go through that with EPA for anything that comes onto the site, and we have to comply. So, there's no flexibility there. And right now, we're slowly excavating. We're doing other things. We're doing some backfill. We're probably going to need the next kind of major tranche of backfill probably 3 years from now, because we're, next year we're going to be doing some other site work, but not as much excavation. The following year we're putting in our slurry wall. And then, so 2027, we really turn back to excavation. So from a timing pattern, I think you probably have an ability to develop another vision and coordinate back with us. But, we looked at 1440 Main Street, before that got shot down, and we actually went out and pre-characterized it because we saw a bunch of, good fill that was available. So, I would be willing to treat it, kind of a similar concept. And then, it's nearby. So there's an environmental benefit and a better price, and, a lot of things better than me having to import it from out of town, so to speak.
Right. And just along those lines, I think it would be helpful. So you and I had a conversation, now it's a couple of years ago, about the pond sediments and whether those would be suitable material. Do you want to just speak briefly about that?
Yeah, as I recall, I think there were, in the data package you sent me, there were some exceedances of, I want to say, PAH,
It was arsenic.
our cleanup levels. And I think the other issue would just be the suitability of, sediment doesn't really compact. It doesn't really come back as like structural fill. And so I think probably the grain size and just think of it as the bearing capacity. We need to be able to put stuff down and compact it with a roller, and let this site be redeveloped, right? So it's got to be solid, not squishy. Is kind of the simplistic way to think about it.
Yep. Thank you.
So Bruce, as Paul, hi. A little bit more on timing. So we, as part of the task force, as Delia said, we're evaluating several different options, and probably within that, several different dredge proposals. The task force probably won't decide on exactly where and how they're going to, I don't know, Chris, early next year, late this year? So we don't know exact the timing, but it's fairly near term compared to 3 years from now. So I'm just wondering when it would be reasonable to start the process of determining whether this material will be suitable or not. Test pits, some test pits have been dug. We've looked at that just for our own purposes. It's I guess we can't say for sure right now whether this soil is available, right? But we might be able to, say that.
Well, that's a question for Jeff as part of DOC, but I think really first, I think we are getting a little bit we're getting a little ahead of ourselves. I think what we need to do is first understand whether the cost for dredging is going to be something that the task force wants to pursue.
No, I understand, but I'm thinking from Bruce's perspective, he has to figure out if this is feasible or not.
Yeah,
So, I mean, Bruce, can you wait a year to figure out if it's feasible? Is that, I mean, so we sit here.
I really think so, because the way I've got our remediation program basically scheduled, we have kind of major chunks of work, and the bulk of the excavation will be after our wall goes in. So I think the timing works. I think if I heard, you got to do a little feasibility analysis, decide if MCI is really, give me a location you're going to put sediment if you do dredging. It sounds like
not
get through
MCI.
that
It's
hurdle.
not MCI. Just to be clear, it's not
sorry.
going to MCI.
So where would the soil be coming from then?
It would come from the pond. It would go into, let's just say DOC. MCI is different, and that's obviously that. Yeah, so it's
Okay.
not MCI. It's DOC land.
Let me just rephrase. Because I'm not trying to confuse things. If you have a borrow soil source available, and you conclude that it would be that you would like a hole made where there's currently a field, and you reach that conclusion, and that's at the end of the year, I think, let me know, and then we can talk about, how big of a hole you'd like to make somewhere, and we can talk about pre-characterizing it to make sure it's acceptable for import to NMI.
Yeah.
Hmm.
So we have time. In other words, I think there's plenty of time.
I think so.
Yeah.
Yeah.
Right.
I have one question, Bruce. This is Keith Hannon on the task force. I guess since the StarMet site would be potentially interested in all this clean fill, is that a cost for excavation that your project would be able to cover
So
and transport?
Yeah, so right now, like with my contractor, I tell them, or they tell me, hey, we need X thousand yards. They go out and find the quarry, the source. They do the characterization built into their price, and then I basically pay per ton delivered. And that would be my cost comparison, right? I have major problems trying to go out and do civil construction off of the Superfund site because with what we do at NMI, I have no permitting requirements. And, going to anywhere else, I have to comply with all of that. So I think that's probably would be, the question. I don't see us being able to really go implement that. But I think if you just think of it as, money's fungible, right? So if we basically established a price for this borrow material, which is what I do with my vendors or contractors anyhow, that price is going to look a lot like what it costs to excavate and transport it. So, I mean, basically, yes, I think there is a compensation we pay for clean soil we use elsewhere. And that could probably, it definitely, my contractors would go broke if they were selling me soil for less than it costs to dig it and bring it to my site. So that makes sense?
Yeah, it does to me. Others
Okay.
understand.
So that would deal with that if that happened, that would not be the cost of the dredging project. The cost of excavating and transport, preparing the receiving pit, that would be some Bruce's costs.
Right. If at the cost of me buying the soil, I think would basically cover the cost of excavating the hole.
Yeah. Okay.
So
Wash in a sense.
essentially that's what we would hope for, is that the excavation cost would be equivalent to the disposal cost.
Yeah, and just, to be blunt, a good chunk of the cost is transportation.
Yeah.
Right. So if I'm bringing in stuff from, I'm pretty far away, right? So less diesel is cheaper and better. And, if this borrow source is very nearby, I have a lot of excavation transportation costs in the book here. I'm almost 100% positive it will be cost effective.
Okay.
Right.
So when you say cost effective, can we say that's like a net
Me-
zero cost?
Yes. Yes.
Okay. Okay, good. That's helpful. Thanks, Bruce.
Okay.
Yeah, so this is good to know. It sounds like this is a real possibility to put into our thinking.
Right.
Mhm.
Yeah.
And Bruce, just so you are clear on, I didn't mean to sort of, just wanted to be clear about what site we're talking about. So just so you're can sort of visualize, maybe I can just pull it up, but the site that we're talking about is the fields that is west of the prison parking lot.
Okay.
That is, you can't see it actually because you're on the phone, but it is.
Right.
Bruce, I think I sent you a map or image of where that
Yeah.
was. Did I?
Okay.
Yeah.
Okay, so
Mm.
it's not technically, that's not MCI lands, that is, I mean, that's the
Yeah.
facility that's being disposed of is on the other side, is the prison proper. And that's
Okay.
obviously under different disposition considerations, so I just don't want to complicate that.
Nope. No problem.
So I do have one more question, Bruce. My name is Chris Denaro, and I'm on the
Okay.
task force as well. And I'm wondering if, we talked about the timing here, and say, for example, the soil's approved, you decide that, yep, it sounds like a good match. And we are reaching a point where we would like to dredge, but maybe you're not quite ready for the material yet. Is that something that we could work out? Is that something that you could take earlier if need be or whatever and store that
You
on
like
your
develop a stockpile?
right?
It really depends on, total volumes,
Sure.
but I think conceptually, yes.
Okay. Okay. Thank
So-
you.
Before Bruce leaves, maybe it might be helpful to hear, I see that Adam has his hand raised, and maybe there are other public questions or comments. Adam, did you have a question for Bruce?
Yes, I do, real brief, and for you as well. I just wanted to confirm, I'm looking at the map, Google map right now, and I just wanted to confirm, is it the field north of Bruce Freeman Rail Trail and south of the Route 2?
Yes, that's
What?
exactly right. So I can,
Okay,
yeah,
so
that's
it's-
exactly right.
Okay, so it's not the one west of Warner's Pond, on the south side of Freeman.
Correct.
Okay, great.
Somebody
I see it.
has, I think maybe there's a television on somewhere. It's a little distracting.
It's probably me. I'm outside. Sorry.
That's okay. That's all right. Let me just share the screen here and show which field we're talking about. So here's MCI Concord, here's the Rotary, Route 2, Bruce Freeman, and it would be this field here.
Okay. Looks like there's a couple of properties there, but 20. Anyway, that gives you an idea. Do you know how many acres that is?
That's about 10 acres. We're gonna actually, that'll be part of another discussion that we're gonna have later in the
Right.
conversation. Yeah. But if
Okay,
you
I
have a
just-
question specific for Bruce on the material.
And Bruce, would you be wanting the topsoil as well as the underlying soil, or would that be something that could be? Sounds like you want something that's more constructible, not necessarily the topsoil itself, right?
The reality is we need both.
Oh.
Generally at NMI, we're excavating 10 feet deep. So think of it as structural fill to bring us back up, but we have to put down topsoil and reseed. So we need both. And just the quantities will differ.
Okay. Just in terms of thinking out loud here about whether some of that could be stored on site and then used as part of your final restoration of the site, but looks like you need some of it anyway. Thank you.
Yep.
And we don't know what the exact volume of the soil is yet, but we're still exploring that. But I think we threw around the number of 40 to 50,000 cubic yards, possibly. I don't know maybe we're still probably in that range, but don't hold us to it. So just you probably need more than that overall. So
Well, we also need at least 6 inches of that topsoil to go over the top of that as well. If you remember, because we have to be able to cap ours as well.
Right.
right.
Well, so this would actually, this would be beyond what the existing capacity of the field is. This would be digging below the topsoil. I mean, maybe some of the topsoil could be given to Starmet, but we're really talking about what additional volume. So beyond so we have Bruce for your, and Adam for your sort of understanding, we have an analysis that 9.5, 10 acre fields, very conceptually based off LiDAR topography, can accept 49,500 yards of just existing capacity, removing an approximate 16 inches of topsoil and removing the 16 inches of topsoil. And then we're looking to see what we can do further beyond that. So the material we believe is really good, suitable material that would work, for your project. So how much deeper can we could go some degree deeper.
You said you did a test bit, right, for water? Do you know what the high groundwater is in the spring?
We didn't test bit for groundwater. We just did soil sampling to see what the depth of topsoil was. Right. So I can share that with you, Adam, and Bruce, if you're interested in seeing what the very, basically Jeff Quick from DOC has access to an excavator and went out. I joined him, dug 10 test pits and looked at the depth of topsoil. Jeff, maybe you want to add to that.
But the other thing is as well, weren't we were reaching out to Mass DOT to get the depth to groundwater readings from them, but we haven't heard back from them yet.
Yeah, I called them. I'm not getting a call back. I don't have any contacts there.
Because they do that regularly anyways, right? Is that true, Keith?
Well, there's 2 wells they drilled in that field, so we're trying to see if there's historical readings for depth of groundwater. But striking out right now.
Can we let Bruce go? I think this would be great.
Yeah.
Jeff, was there anything that you wanted to add to the conversation?
Yeah, just that if we're removing some of the gravel base when we strip back the topsoil, we are still going to need a portion of that to mix with the dredge material to stabilize it before we apply a 6 to 8 inch layer of topsoil over it. We just have to keep that in mind.
Yeah.
Okay.
Yeah, I'm not worried about, you guys delivering all of the topsoil or anything else. I, hear this as it might be cost effective to, even get some of the common fill, right? So if you need to preserve topsoil or some of it, I'm not too worried. My only obligation is going to be to show that, the decision on whatever I procure is cost effective. And that's by comparison to kind of buying it on the market. So, and like I said, I think we'll meet that test.
Great.
Okay.
Sounds
Thanks,
good.
Bruce.
Thank you so much for joining us.
Thank you.
Today. Appreciate
Thanks,
that.
Thanks, Bruce.
Sure.
Thank
All
you.
right. Bye-bye.
Bye-bye. Okay, Adam, so I guess you're up. It's your turn to share about Milford Pond.
I have quite a bit of information that I can share, and I'll just go as quickly or in depth as you want. And so I'm going to just start. I'm going to share my screen if I can. I'm going to do that if I can figure out which one it is. Oh, yeah, it's this one right here. Okay. Yeah. So that in a moment here should be sharing. Can you see anything?
Yeah.
Yes.
Okay. I see it didn't highlight it as being shared, but I guess it's being shared. So, okay, great. And so what you'll see here is this was an aquatic ecosystem restoration project under Section 206 authority of Water Resource Development Act. It's a cost sharing authority where we can right now we can work up to about $15 million in projects. It's a 65-35 match for the actual construction. We also cost share in the feasibility, and we have to meet federal standards for feasibility. And so there's a few steps involved in doing the feasibility and then going through the contracting. But anyway, that's just the background of this. The town actually came to the Corps asking if we could do something to help them restore Milford Pond, which is down along 495 South. On the west side of 495, it's actually the headwaters. It's actually on the Charles River, when it's no more than just a small stream down there, but it actually is on that actual main stream of what becomes it's actually named the Charles River, but it's very small. And if you can see the screen, it's coming down through here. There's actually an impoundment right here. You can see my hand.
Mhm.
That's an impoundment. It's about approximately 8 to 10 feet high. It has some stop logs on it as well. This used to be a large natural bog that the stream flowed into, and then it was impounded. And a lot of the bog and native swamp wetland, tree, it would be like a treed wetland, was impounded by shallow water, and all of the forest habitat was killed off over time, and then became basically just shallow aquatic habitat. Maybe a lot of this north area of the pond is only about 3 or 4 feet deep. It was anyway, and so in other words, it used to be just a like swampland that was, healthy forested wetland that then became shallow aquatic habitat. And then there is a deeper portion that, at least for a long time, was open water, and that was an area that is now shallow enough that it's just became every single year it became completely 100% choked in macrophyte aquatic plants, many of which were invasive, like milfoil and curly pondweed, and then literally was growing up to the very surface of the water and totally choking it off, making it into basically an anoxic, a nightly cycle of low oxygen. And it was really becoming inhabitable for a lot of different animals that used to be able to inhabit this, at least as open water. So anyway, I'm going to go on here and just explain that we have to I'm hearing some talking behind.
Yeah.
But anyway, we go through feasibility phase, design phase, construction phase. And what we did is we were able to go through a planning process where we identify, the opportunities, we inventory, formulate alternative plans, and then we select a plan, and then we go to design implementation if we have an acceptable plan that actually has, and remember, in this program, we have to have an aquatic ecosystem restoration benefit. It's not necessarily a recreational benefit. It's not like a flood risk management benefit. It's for environmental restoration. And so we have to measure our benefits by how much environment we're improving. We don't necessarily have to restore habitat, but we can improve it as a minimum anyway. So anyway, we had some constraints in this pond. We had a large area that the town takes water out of. It's actually a well field. It's like a shallow sand point wells that are all connected together, a complex of maybe 100 or 200 shallow point wells. They're actually in the pond, and they push down into the sandy sediments below, and they use that as their primary drinking source. And then we also had a large, not a very large area, but an existing emergent habitat of mostly, it was fairly healthy emergent habitat of cattail, native cattail and other species that 4 listed waterfowl species were using as basically they're state listed, not endangered necessarily, but at least state listed and protected. And they're I don't know if you have any around your pond, common moorhen, least bittern, pied-billed grebe, and king rail. And what they need is a combination of open water and immersion. So we were looking at trying to restore some additional balance for them. And we also have an existing dam that the town didn't want to remove. That really wasn't an option to remove that. A couple of reasons, because we had this habitat that we didn't want to just drain. That was the state listed bird habitat. It also worked a little bit as a detention basin for flooding downstream, immediately downstream into the town. And so there was some run of river, but there was some detention that could be held behind the dam, not just from the surface of the impoundment. And this gives you an idea of kind of how it looked before. It was just completely choked up. Even where it was 6 feet deep or 8 feet or even 10 feet deep, it was completely choked in the summertime with macrophytic growth that basically rooted vegetation that was growing up to the surface. We had a balance of where ultimately we want a balance of aquatic plant beds, open water, and emergent wetland. So we were looking for that balance for these, particularly for these birds that need all 3 of these. And these are some of the considerations that we're looking at, and would probably be similar for Warner's Pond, where we have a slightly like a tannic water. It's not totally super clear. So at 12 feet, there was enough reduced clarity in the water that at least we hypothesized, at least that if we went down that deep, that the rooting vegetation would have a hard time rooting. It might spread in from the sides slowly, but it wouldn't just be able to root and grow from that depth up. Whereas at 6 feet, it was growing fine. And 6, 8 feet, it was rooting fine, was getting enough sunlight. So we wanted to get below around 10 to 12 feet. We also wanted to reduce the phosphorus loading that was in the soil, that was in the sediment in the pond. We also obviously wanted to enhance the threatened and endangered species and so forth. So then we looked at possible measures. We looked at hydraulic dredging primarily because we really couldn't drain the pond. So we had to really go in. We couldn't just mechanically excavate. This was very fine-grained material, mostly organic, very, very wet material, up to maybe 80-90% water content. So even though we had a good depth of sediment, it was primarily water. In other words, if you dried that out, you could shrink it down by quite a bit, if you got it above the water table. And we looked at ideas about, could we pump it to another location off-site? Could we use geotubes? Could we find, let's say, a large an area where we could dewater, like you're talking about, like a field where we could actually build berms or actually excavate. But we really don't have that here. It was about a 10-acre area, but it was very wet. There was no chance we could go in and do anything with it. We also then looked at building within the pond itself. We had this huge area that was only maybe 3 feet deep, 3 to 6 feet deep, completely choked. And it had originally been emergent wetland and forested wetland. And so from a restoration standpoint, we could actually do similar to that, this portion of the pond that removing the dam would be if we were to fill it. We could actually convert it back to what it was originally. And so that's why we considered it restoration, because even though we weren't moving the dam, we were actually restoring a portion of the dam back to the emergent and forested wetland characteristics that it had once been thriving there. And again, we couldn't look at dam removal. We also were limited by $10 million costs, so we couldn't do. There's a lot of processes where you can actually pump and dewater the sediment by using, let's say, a plate and frame or a filter press. And that's a very slow and very, very expensive, time-consuming operation. You know, you're lucky to get maybe maybe 10,000 cubic yards a year or something. And it's going to just be very expensive and lots of double and triple handling of the material, because you'd have to dewater it, and you have to deal with the dewatered water. And then you have to, and you usually have to put a flocculant into it. And so you're impacting it with the flock. It's an enzyme that actually, it kind of curdles the sediment into something that can dewater. And we found that to be just very cost ineffective. So we also couldn't dredge the entire pond. It was just too costly, even at the cheapest rates. There was no way we could do the entire pond. So we kind of focused in on a 17-acre portion of the pond that was kind of a primary area of the pond, and it had a boat ramp and some parkland near it. And so we felt like that was a good size that we could maybe handle. And that ended up being about between 160 and 200,000 cubic yards to go from maybe 4 to 6 feet down to 12 feet. And that was, again, that really saturated, organic, rich soil. 160,000 cubic yards is, by the way, what we ended up dredging. We also, looked at these various species of birds and animals. It was not an anadromous fishery, by the way. There was no, migrating fish coming up there. Then we compared different alternatives. We were looking at least 15 million for using belt press and geotubes. Partial dredging, we were back in, this was before 2020. We were looking at about a $5 million project to be able to dredge the 160,000 cubic yards. And so we actually selected this. What we did is we identified a 30-acre area within the pond that we could pump the material and let it settle in place in water placement site. And so what we did is we built this detention basin that was, it explains it here, 30-acre in-basin area, was already a shallow aquatic bed. We built this coir log, which is a coconut fiber log. They compressed the coconut fiber together into these logs that are different diameters, and in this case they were 16-foot diameters. We were able to place them in and around the 30-acre perimeter, push them down in place, hold them in logs, and then we were able to just directly pump right into that basin that we created. And we used a 12-inch floating hydraulic plant that it's fairly easily transportable at that size. It can come in, it's like the size, a little bit bigger than a large catamaran or something like that, you know. But it can be brought in if you have any kind of access. It wasn't we had a paved access with a boat ramp, and they were able to use that. I don't know what kind of access you have, but there are smaller units too, by the way, that like a mud cat. This was an Ellicott dredge. There's mud cats that are a little bit smaller than that. They could probably go in on like a back road as long as you could launch it or lift it off with a crane or something like that. Anyway, what we did is we were able to go in, hydraulically dredge the material down to the 12, 13 feet deep, pump it directly into the site. We allowed it to dewater on site, and really they didn't have to add much water to the material because it was already so saturated. You know, if it's sand, you have to actually add a tremendous amount of water to the slurry. You have to create a slurry out of it to transport it through a pipe. But in this case, and maybe in yours too, you pretty much can just put the cutter head right down into the muck and just and pull it up, you know, basically 100% sediment. So it becomes fairly efficient that way. And it comes out as a big slurry at that point. And in our case, it didn't really dewater much because we were just dumping it directly into the open, shallow water. And so then we just let it settle in place. We allowed, there were some areas that were built up naturally just from the outlet of the pipes that then became like maybe 2 or 3 feet above the water level. These berms that formed that, you know, just from the outlet of the pipes, and that formed about 2 acres of islands, which we were able to go in, and once they settled and dried out, we were able to go out there and walk on the islands and plant with native trees. And just to give you an idea of the locations, here's the dredge area. This is the placement area. And then what we did is we went through these steps here. We actually were able to implement the project around 2015 through 16, and then 2017 we actually planted some native Atlantic white cedars on those 2 acre islands, and then we've been monitoring it ever since. This kind of gives you an actual idea of what we dredged and where we placed the material. Here's just an example of, you know, the dam. We had to just put a floating curtain just to maintain, but we really didn't even need that because there was really no sediment created from the hydraulic dredging. It's very clean, and because we were containing the outlet pipe within that coir log structure, we didn't really have any escape of sediments there either. We just let them filter through the coir log. Here's an example of what the coir log looks like in place, you know, prior to actually starting. This is the coir log structure, and this is what I'm talking about. It's just, you know, you can see a lot of floating macrophytes, but there's also aquatic species underneath the water too. So it's a whole combination. I think this was an early shot here. And then this is the actual machine here, that the plant that dredges. This is the cutter heads in front, and it actually drops down and it just sweeps across, and then they can move this by they move it ahead, and then, you know, just keep lifting and dropping the spuds, and they just keep moving it forward, and then, you know, making progress that way. And then this is just a floating pipeline. You can kind of see it floating along. And here's what it looks like floating. And you can go a long way with these. We were going, you know, maybe about a mile total. but you can go pretty far with these floating. And then if you're going up and over a hill, you can get up about a good 10 feet or so, maybe. And we can actually go up and over a hill before you need any kind of additional supplemental pipes to lift the material. But so in other words, you don't need anything like that. You could easily go to that field you're talking about. This is how you can see it coming out of the pipe here. It's just basically a slurry and it becomes this big muck slurry. This is basically how it looks when it comes out. And it just slowly filled up this whole area, like this. And then later, this is an area where once it was finished, this became kind of a hardened surface that dried out. It became kind of a hard peat surface. And we were able to just walk around and plant trees in here. This is the area that we end up dredging to 12 feet. This gives you an idea a couple of years later of what was generated here. This is all regrowth that came in naturally. Here's the coral log structure. This was just the natural open water that was shallow. And this cattail back here it created a habitat from the fill. You can see kind of the difference here between the two. And it just gave you an idea. And then, over time, we started seeing more vegetation. A lot of trees were starting to grow on this upper reach, like this. I think that's a sweet birch or black birch. These are the Atlantic white cedars. There's some poplar coming in. And then just before and after, this is how it looked before, just, completely choked up. This was a small immersion area, but most of this was just open, shallow aquatic bed. And then later, this is the actual area that we formed into a big immersion wetland. You can see this kind of this kind of tannish green color. That's the cattail that's come in. There's some native cattail that already existed. Here's the open water. And then this was the remaining part of the pond that we didn't do anything with. And we allowed, by the way, the flow of the stream to go around this whole area here, so we didn't impede the stream. But that's it for my for this presentation, and plenty of questions if you have them. But again, we went out, by the way, in 2024, and we were able to evaluate this open water, and we had basically no vegetation coming back. It was still 13 feet deep, and it was very successful in terms of the vegetation not coming back. Now, you could do a little bit of herbicide treatment if you really needed to, but we found that wasn't absolutely necessary, at least in the areas that we made deep enough.
So Adam, how long do you anticipate that dredge area staying like that?
Okay, well, there's no real good source of the sediment coming in there. There's very little suspended load because we have this upper area to settle out anything that's coming from the stream. A huge basin here for natural settlement. There's a lot of capacity. So the only thing coming in is just super clear water, a little tannic. But in terms of sediment load, is very little. So pretty much the only sediment load we had in here was, if you have like stormwater outflow, but if that's contained and controlled by the town, and you don't have a lot of that kind of impact, then you don't have to worry about that either. And so the only thing that was really causing the sedimentation was just organic buildup, just organic vegetation that would grow prolifically, die off, and then you would get some rotting, but a lot of it was just settling, like because it was basically in a anoxic environment. It was just sitting there becoming peat, basically.
Mhm.
So we had this, a huge layer of just compressing organic aquatic bed habitat. Not something like a bog moss or something. This was just the curly pondweed and the milfoil and other species that were forming, just basically an organic debris.
Right.
So
in
so
the
as long
case
as
of-
we're keeping that from happening, we don't anticipate that this will fill in very quickly at all. Unless the vegetation slowly creeps in and you get rooting and new vegetation growing in, that would be the only source of sediment really over time. And then the other one would be just floating vegetation, like if there was anything that wasn't rooted, obviously that could become, an organic source for.
Adam, do you have phosphorus measurements in the open water before and after? Did the removal of sediments actually have effect on the water quality, or?
I didn't take any water quality samples after, no, but we did have high phosphorus loading in the sediments themselves. And a lot of that was from previous, untreated septic, and a lot of different reasons why
Right.
that was a problem. I mean, there's a residual phosphorus loading that occurs in these ponds and then gets recycled by the vegetation.
So you were saying the filling of the pond was organic debris rather than upstream suspended sediments? I'm just wondering.
Yeah, a
There's
lot of it was.
There wasn't a big source of suspended sediments upstream filling the pond?
No, because we had a very, very small amount of inorganic in our sampling. It was very high organic content to
Yeah.
begin with. So,
So in the case of Warner's Ponds, that it's a very large watershed. It's 45 plus acres in size, and most of
Yeah.
that is outside of the town of Concord. So we
Right.
don't have control over, what is coming into the ponds, which is basically at the base of the watershed. And there are some, Mass DOT has a storm drain, and there are town storm drains that go
Right.
directly into the town, into Warner's Pond. So do
yeah,
you
and
have any
if you have
sense?
an area where you don't dredge the entire thing, but you're understanding there's going to be some sediment load coming in over time, and you can kind of predict what that is. That would be kind of what we were anticipating, is some sediments were going to be coming in as bed load and inorganic suspended load. But again, we have a pretty big area here that's going to settle out before
Yeah,
it gets into
like
where we dredge.
yeah, you have a nice big settling basin.
Right. So there's many years worth of could be 50 years or more before any of that sediment reaches equilibrium, where it starts actually coming out. It's like a deltaic deposit or something here.
Yeah. How big is that area that is sort of
Yeah, so this entire pond, I believe, is about 50 acres.
how big is that settling basin?
Oh, the settling basin is about 30. So maybe it must be bigger than 50. I guess it's this was about 30. This was 17. Okay. So the entire.
So 2 to 1, essentially.
Yeah, but now what's interesting though is I did some settlement on similar material in 2 other ponds to see what it would look like, and we found out that we could, if you bring it above a water table, this particular kind of material, it doesn't have a lot of clay material in it. It's mostly just like an organic debris, maybe silt-sized organic debris.
Yeah.
And what happens with that is it doesn't have the colloidal properties of clay, and so it can dewater very quickly when it's brought above a water table. And we did some testing on 2 other sites of similar kind of organic rich fine grains sediment with low amounts of actual mineral clay. And we found that it was a nice curve. Within days, we were getting a lot of dewatering. And it dewaters in two different ways. It settles a little bit, so any water you entrain into it, it will settle out pretty quickly within a couple days and form an upper layer of any water that was entrained by the hydraulic dredge. And then the remaining water, as long as there's a way for the water table to drop out through that sediment. In other words, it's not just sitting saturated like on a sand bed or something like that, where there's actually gravitational push. I guess it's pull actually on the water through the sediments. We found, through our testing, that only took within a several days more. We were getting dewatering and then shrinkage, pretty rapid shrinkage of the entire material. It would consolidate. So in other words, what would be, let's say, a meter high, let's say, core saturated with maybe 80% water would shrink down. And we found that when it got down to about 40 or 50%, or maybe even 30%, maybe even that low, it started slowing down, because then at that point it was becoming basically just a wet, alluvial soil at that point. Where at some point it can kind of retain some of the moisture, but it was able to shrink probably 2/3 in terms of it very quickly. Within days, it shrunk to basically 1/3 of its volume. So if you're dealing with, let's say, in situ of 100,000 cubic yards, if you put that in that field, you would end up with about maybe 30 or 40,000 cubic yards of actual fill at the end.
Right. Right.
And then
I mean,
it
I
would
think it
continue
depends. I
drying
think it
over
depends a
time.
lot on what the sediments consist of, but
Yes.
that's my understanding as well, that what you're pumping is one volume, but there's so much water that's accumulated within that in order to carry through, for a hydraulic dredge.
Well, it's two kinds of water. One is the water you entrain into the pumping process, and the other is just the water that gravitationally can stay saturated within the material underwater, because the material becomes a lot lighter underwater, so it doesn't compress anywhere as quickly as it would once it's dewatered. It shrinks down to very small, a very small amount. And if you let it completely desiccate, you can shrink it down to, maybe 20% of its original volume.
How long does that take to dewater?
Well, in at least in our bench test, we were able to dewater it. I could look, but it was within a week. We were looking at down to about 30% of its original volume.
Oh,
It's pretty quick. As
right.
long as the water can leave the site, any water that comes to the surface as it settles, you allow that to run off the top.
Mhm.
And then you allow the rest of the water to just percolate through some substrate.
Right. But I think, Chris, it's going to be, it's pretty site specific and sediment specific. So, if you have, well, I mean, I don't think that we have enough information about what our materials consist of and what our
Right, but it's
final
pretty,
disposition place or dewatering place is.
Right. but it's pretty
um,
interesting to have that in our minds, in our planning, to understand it better.
I don't think we should have that in our planning, that it's going to take a very short time, if this, a short period of time. I think that is something that we need to, that's a question that we need to
Right.
be asking.
Well,
Right.
the dredging process itself takes many months. I mean, if you were to dredge 160,000 cubic yards with a pretty decently large piece of equipment, it still takes 6 months, so during the time at which you're pumping it, it's settling, so you have a lot more than 5 days that you have to
Right.
you're pumping
Right, I
it in
understand that.
continuously. So
Yeah.
it kind of hits an equilibrium where it's dewatering, settling as you're pumping it in, because you're dealing with
Right.
a 6-month period, basically. It's not a short term from that standpoint.
Right.
Well, thank you very much,
But I
Adam.
would say it's quicker to drain pretty much than it is to hydraulically dredge, unless you have a completely saturated situation. If it's saturated and it's in water, then it's not going to settle that quickly. It's not even going to really dewater. It's just going to sit there like a slowly sinking, slurry until it gets back to its in situ depth.
Mhm, mhm.
So that's what happened to us anyway. We didn't expect any shrinkage, and we just saw some dewatering of the additional water they added to during pumping, which wasn't much. That was able to leave the site, but other than that, we pretty much had a 1-to-1 because we were pumping it directly into an open water. But if we were to have pumped it into like an open field where we could let it just dewater and completely drain down to maybe 30%, 20% water content, like a wet alluvial soil, like a farmland soil or something. You can expect it to get down to that kind of an equilibrium.
Mm.
And then it becomes basically just a nice organic loam at that point. It's not going to have a lot of organics. I mean, a lot of inorganics, but it's going to be something that could. We have another example where we were able to drain an impoundment, let the material just drain in place. We just dropped the water table below all the sediments, and within about a month, you could drive equipment over it, and you could actually plants were growing. It was just a lush vegetation growing on the site, and it shrunk quite a bit too. It became basically something you could excavate with an excavator. So in other words, if you allow it to drain and have an effective way to get the water table down below this material, it will drain effectively and also shrink, dry out.
Right. We're looking into, we don't believe that we have the ability to do that at Warner's Pond based on,
No, right, yeah.
The constraints of the dam. There's the possibility of pumping over the dam to see if you could dewater.
Yeah.
But that's, additional cost. But
Yeah.
those are helpful thoughts. I'm wondering if there are any, well, one question before we go off the task force. Would you be willing to share this set of slides?
Yeah, I would. It's let's see, I could make it into a PDF because
Great.
it's a fairly large. Well, I have a PDF here. I'll have to see what size this is. But
Yeah, if you could send that to
definitely
me,
get a
then we could
decent
post
amount.
it to our task force website. That'd be really helpful. And then I just wonder if there are any members of the public who have any questions for Adam. Thank you so
All right.
much.
Yeah, you're very welcome, and glad I could help with this better understand. You're trying to better understand this process here.
We appreciate it. Thank you.
Thanks,
All
Adam.
right.
Thank you, Adam.
Oh, before
You have a
you
question?
go,
Yeah.
there's,
We do have one question.
All right.
Anna Feldwig?
Yeah, sorry. My question is, why wouldn't this work at Warner's Pond?
Well, what wouldn't necessarily work is we were talking about a mechanical excavate, draining the pond, allowing it to drain in place. That was just that final example that I gave that we did not do here. In this case, we left the pond, the entire impoundment in place, and we hydraulically pumped the material out. And we could have pumped it, if we had had a location, we could have pumped it into an upland site just as easily as we pumped it into the pond. And no, what we did here, you could do at Warner's Pond, and you might even be able to do more than that if you have a site off-site. You would need to test the material and make sure that it can be treated as a general fill by the state of Massachusetts, by the Commonwealth. By the way, if you're going to take it off-site, and I think they might even consider that off-site, into the adjacent field. Whereas if you put it in the pond, but you'd have to actually sacrifice a portion of your pond if you wanted to build something and have it pumped right into the pond. Otherwise, if you pumped it off, then it would just have to meet off-site Massachusetts standards.
Well, I think that's a key question, Anna. You could do this if you had 17 or 20 acres of the pond that you wanted to fill in. But it's not, you have to, this is more than dredging. This is dredging and disposal within the pond.
Yeah, and I'm just saying that that's one way you can
I'm
do
sorry,
it.
Anna, could you just clarify, like, what do you mean when you say, why can't this be done at Warner's Pond? What?
Well, I wasn't clear on what the differences were between this situation and ours.
It's a disposal. This is disposal in pond. And
Yeah,
taking
but
wood
we've
from
talked
the
about
pond.
that, right?
Yeah.
Yeah.
Right,
That's
so
one.
I think, I mean, from the standpoint of Warner's Pond, if you were to take what was the cubic yardage, Adam, of what you dredged? Your pond is, 160,000.
cubic
And
yards. And that
it
was of
is-
the in situ material.
It's a much larger pond system, so it's obviously not apples to apples, but say it was half that, because I think roughly Milford Pond is double Warner's Pond. Is it about 120 acres?
It could
Adam?
be that big, yeah.
Okay,
By the time you take in the entire footprint, it could be, maybe somewhere around there, 100.
so if you took 80,000 yards of dredged material and tried to find somewhere to put that within Warner's Pond, you would essentially fill in all of Warner's Pond. It's just not big enough to accept at the depth that it is, unless you wanted to sacrifice the deep hole, so that's kind of part of the analysis of how much material could you move within the pond. It's not very
Right.
much in Warner's.
Right, yeah, but we do have the other options of taking it off. I just wondered, I just wanted to clarify what the differences were, but thank you.
Yeah, and in our case, we could have, if we had had a place that worked, we would have probably very seriously looked at an option of not filling up the pond, but pumping it out into a settlement area that was an upland site. But we just didn't have that here like you do at Warner's Pond. We didn't have a large field in the ready that was dry with a groundwater that was low enough down that would actually drain the site, drain the material. So
I think one of the reasons, Adelia, if I remember, that we wanted to look at this situation, it was a well-established, well-designed project, and we were wondering what the long-term success would be.
right.
And if you did this project and you still had invasive plants coming in the short term, but this seems to be a longer-term success thus far. So we were looking for the long-term success of a dredging project,
Right,
which is
that's
good.
right. You did mention herbicide treatment, and if you could, is that aquatic herbicide treatment or is that terrestrial?
Yeah, it would be aquatic if you ever if you wanted to then maintain, if you were having vegetation encroaching back, you could
Okay.
in theory, kill that vegetation by herbicide treatment. And we did have a terrestrial problem too. There was some Phragmites in 2 different locations that had to be treated, and the town has to continually treat those sites so that they don't grow out into the cattail marsh.
Right.
And it's something that they're just going to have to deal with over time to maintain that Phragmites to control it. Anyway, but again, if it is a possibility to take that pipe into another area that could hold the material that you're pumping and allow it to dewater pretty much as quickly as you can pump it in there.
Hmm.
Anyway, so it is, I would think, feasible from that standpoint.
Very helpful.
Yeah.
Really appreciate your time, Adam. Thank you very much.
Yeah,
Thank you,
definitely my
Adam.
pleasure.
Appreciate it
All
very much.
right, take care.
Thank you.
All right, I'm going to stop sharing and I will probably
You're
see
welcome to
everyone
stay
later
if
at
you'd
some
like.
point. Yeah.
Yeah, but you're free to go if you'd like to. So
Thank
All
you.
right. Thank you very much. Bye-bye.
Bye-bye. Okay. All right, so before do we want to talk about that right now, or do we want to, any questions, comments?
I just think it's a good success model. That's what we're looking for, you know. Because, you know, if we did dredge, and would it have a long-term benefit? It sounds like this is a good example that the answer would be yes.
I thought it was interesting too, that they dredged 12 feet. And he said 8 feet was, he didn't feel that that was deep enough because there was some there was some rooted vegetation growing at 8 feet. I thought that was interesting.
I think 8 feet is the minimum. That's,
Yeah,
and the deeper, the better.
right, right. So I think we should consider that as we,
Yeah,
you
I do
know,
too.
figure out how much, what's the quantity, where, and how deep.
Yeah, I think that's, so we landed on 9 feet to get a larger area. But if now we have more capacity at the North Field, I think it's definitely worth looking at, 12 feet.
Okay.
But Christine, I think you just, maybe it's a segue into the next thing. You just sort of define the parameters of our proposal or proposals, you know, how
Right.
much, deep, and where.
Right.
Those are the
But
three.
before we go to the proposals, we
Okay.
need to do 2 things. The
Yeah.
first is the minutes, but the other thing is, who has not yet taken minutes, who is volunteering to take this round? We didn't establish that at the beginning of the meeting. And it will be recorded. You have a transcript to work from. But we need somebody to sign up for that.
I haven't done it yet, so I'll do it.
Okay, Chris.
So then, all right, then before we go deeper into our meeting, why don't so let's take a look at the minutes from the last meeting. I know that there were some, I don't think I saw, were there changes on that one?
I
Some-
did send some around today, and I'm gonna pull them up right now.
There were a few, but they were pretty minor, I thought.
Yeah.
Yeah,
So
So-
do I have a motion then to approve those minutes as amended?
I make a motion.
Second,
Okay, the minutes from, gosh, what was the date of that meeting?
September 23rd.
September 23rd, are approved. Okay.
Mm.
All right. So now we go on to so I think we should just go right into our discussion on the proposal. And I think the good thing about this, we'll talk about it tonight, but we also, Paul, you won't be here tomorrow night, but we also have actually a big chunk of time scheduled in our meeting for tomorrow night to also continue with this discussion.
Oh, that's perfect because I actually have another Zoom meeting right after this with my tribe. So it's like, so I'm gonna bow out at 7.
Okay, all right.
So I can't really go much longer today,
okay,
but I'll be there tomorrow.
okay, great.
I think
Perfect.
without discussing the details of the proposal, I want to understand sort of what the proposal looks like. Are we actually going to discuss several different options for dredging, different amounts, different? So,
Yeah.
I think the answer is yes.
Yes, and thank you. Your comments were great. I threw something together. It was just a very initial draft.
Yeah.
So appreciate you taking it to the next step. I think we'll keep modifying as we go. And I'm just gonna, anybody can pull it up if they have it available. But I can find it and share
I
it.
didn't think
Yep.
the depth of dredging was one of the parameters we were looking at, but maybe it is here. Is that an
Yeah, I mean,
option?
I think we kind of thrown out, like a range, but I think we should take a look at the 10 to 12 feet.
Before we get too far down, I'm just wondering, is it possible to put this on a Google Drive link so we can all access the same document?
Good idea.
Not
Yeah,
worry about version controls, because this is gonna get a
I
little.
think that, I totally think that's a good idea. I'm not, we had our planning meeting today and I said to Toby, put those up on so I can see them in my Google Drive, and he shared them as a Google Doc, but it doesn't come through as a shared document in my, so, yes, I think we can figure out a way to do that. And does somebody want to volunteer to look into?
Yeah, I can take this latest version or whatever latest version you have and make it shareable on my Google
Okay.
Drive.
Perfect.
So
I think that
we
would be
had
really helpful.
two major areas that we needed to fill in. One was the disposal side, right? The volume. And we're kind of getting closer to that. The other one was the cost. And I think we needed both of those to get a proposal in place.
Right.
I forgot what our tack was on getting cost estimates for.
Yeah, so I can speak to that a little bit because we had talked at the last meeting about getting a bathymetric survey done by a professional land surveyor, and then we brought that to the task force, and thought it was going to be pretty short money. The task force did approve us to go out and find that person, and in my initial forays into understanding what that cost would be, it's not short money. It's like, the only cost that I've got, and they are the gold standard, is from a company called CR. Well, actually, I don't know, because I probably shouldn't share too much just from I don't know. But the cost was over $15,000. And that's not, to me, that's not a small cost. So we talked about this internally with the engineers, and really what we're trying to understand is what is the cost to understand dredging, at a minimum 35,000 yards and placing it in the North Field. And so the stormwater engineer and I feel like we can come up with a fairly decent estimate, not, or scope to give to some, contractors to give us a number, right? So if we take those dredge plans that have what we understand are, the depths, and we can talk about this, but the depths that EA used were the ones from the 2017 ESS numbers. Those, we've determined there's a discrepancy, but relatively speaking, those numbers are fine. We just need to get a cost. We just need to understand what is, your cost for dredging 33,000 yards, 50,000 yards, 100,000 yards, and using it in a field that is not restricted. So you can basically just go from point A to point B to really understand if this is something that we're going to pursue. So I guess at this point, understanding that the bathymetric survey cost is going to be much higher than what I had anticipated, I think we maybe want to shift gears a little bit and just say,
Yeah.
let's just get
Yeah.
that
Absolutely.
cost, because, you know, if we do decide to pursue dredging, then we can have that bathymetric survey done at a later date.
Yeah, I think what you're saying is you probably would need that for an RFP, but you
Yeah.
don't need that for an RFI. I mean, can you?
Yeah, and we actually don't even need it. We need it because the engineer that put her stamp on the dredge plan feels like she was bitten by bad data. And she is not going to, you know, put any stamp on anything until she has PLS data. I've talked to other firms, do you generally get PLS, which is a professional land surveyor? Do you generally get that stamp when you go to dredge design? And they say, no, that's done during the dredging process. So, but I don't blame her if she feels like this information was, questionable and it has caused concern. And so she's, has concerns about that.
So Delia, how would you go about getting a cost estimate? It's not a formal quote.
No, so it's a request for information like we're doing for the dam removal cost estimate. It's it's a similar process, but you're not awarding, there's no expectation of an award for work.
So basically you could take the dredge plan from the 35,000 and just change the disposal.
Correct. That's
part of that.
exactly.
And we could start with that and they could scale it up, see what that number is, and then
Right.
maybe you could ask for 3 different amounts, but I mean, just getting one amount to see if it's in the ballpark, then we could scale it up from there. Yeah.
Well, I think it's probably what we talked about that too, and I think it's worth getting, understanding what is it just a linear scale up cost, or is it something more complicated than that? So if you go from 30,000 to 60,000 to 120, is it just a double, or is there some other?
Yeah, I don't know, Keith, you probably know this better. I don't think it's linear because I think there's mobilization, there's startup, there's staging costs, and then those are probably the same for whatever volume. But I'm just guessing here.
Yeah, I think there's an efficiency there. So the more you do over a larger period, it's going to be cheaper per cubic yard. But yeah, I mean the staging areas and whatever is needed in that farm field probably won't need to change if we cordon off an area but the dewatering setup will need to change with more material. So that'll probably be the biggest shift in cost in addition to cubic yard,
Yeah.
rates changing.
And if we go for one cost, wouldn't it be more efficient to get a couple of 2 or 3 different options at the same time? Instead of going back again and back again?
Yeah, I think that's where.
Yeah, I agree. I think you might as well. I mean, I think we can assume that fields can accept, yeah, I think the fields can accept as much as we want to suggest. And Jeff, I don't know if you have thoughts about how deep we would want to make an assumption there. We didn't really have.
Yeah, I'm not sure. I'm not sure we need to focus on that so much because we were able to determine that the removal costs will be a net zero cost for the town. So, if we want to.
I'm just saying that if we hit like unsuitable material.
Yeah. Like bedrock.
Yeah.
Or
we just need to get a rough order of magnitude cost estimate and not worry about.
Yeah,
details.
I think that's right.
Really,
That's right. Just
what practical limitation do we have for in-pond disposal? I forget what what volume we had there originally.
Well, that's where the 14,000 came from.
Yeah, that was all in pond?
That was all in pond.
That was the fill that Western Cove, which is pretty
Yeah.
shallow. So you could put more at different areas of the pond, but then you are giving up some open water.
Yeah, I mean, you could fill, I don't think successfully, but you could fill some portion of the deep hole. But the
What's the-
channel goes through there, and that's also the only deep hole in the pond. So-
What's the habitat impact? Like for the birds, the fish, I mean, with that sort of that fill in pond fill as well. I remember
I
that's
think Yeah, I mean, I think you can you can have some really good improvements if you made sort of those very shallow, but not, if you made them emergent wetlands, I think they would have a huge, you might have pied-billed grebes and least bitterns and those T&E species that they have at Milford Ponds that we don't
Right,
have at Warner's Ponds.
that's why I was asking. Yeah, that
Yeah,
Is the breaking point sort of the aesthetic part of it when the pond becomes more of a channel? I mean, I'm just wondering kind of what the breaking point is, because to our earlier point, yes, you could fill in a big portion of the pond and then you have something that looks like dam removal, right? You have a stream running
Right.
through. Is there a technical breaking point, or is that sort of a character breaking point? I don't know what the answer to that is, but I mean, is that one of our options? Would we go to 28,000 cubic yards in the pond as opposed to 14? I don't know if that's an option or not.
so this is different because we haven't been talking about in pond placements. We've been talking about disposing at the fields. And I thought, and maybe it's something that we still need to be discussing. Do we need to be further evaluating, in pond placements and what?
But I only bring,
Nobody's come up with the volume that's acceptable. I mean, part of it with the 14,000 was that's what 3 million can get you, and that's not going to fill in so much of the ponds that it looks like dam removal, right? But what that actual number is it 20,000 or is it 30,000? We haven't looked at that, and maybe this group should be talking about that as part of the some.
Well,
One of the things that we had talked about as a whole group, whole task force, is that we were talking about sediment. And we were saying, well, if you just move it within pond, then what are you doing with the sediment? You're just moving it around and you're not getting rid of it. And so I know that we had talked about keeping some in pond, but trying to remove it, because wasn't that part of,
Yes,
so to speak, cleaning the water or making it, I'm not sure what the correct technical term is, but.
well, Christine, it's interesting because I've asked that question repeatedly about what is our goal? Is our goal sort of plant removal and open up the habitat, or is it phosphorus reduction through sediments? Like, I originally thought it was both, but I've heard more recently it's the former, not the latter, because we're not removing enough sediments to really have a big impact on the phosphorus. That's why I asked the question earlier of Adam.
right.
So I don't, you're right. If we just move it around, we're keeping, the nutrients in the pond, but
It doesn't matter. That doesn't matter. I think we need to look at it as, so moving the sediments within the pond, you can improve the habitat within the pond. So you can create an emergent wetland system that will be an improvement over the aquatic invasives that are there now, right? The phosphorus, you are never going to, unless you dredged the entire pond down to a gravel, or sandy subbase, you're never going to remove enough sediment and thus phosphorus to make it basically an oligotrophic pond, right? Something that is not impacted by high phosphorus.
well, and I think
Phosphorus is a concern because it's contributing to this rooted plant condition. It's not creating cyanobacteria blooms, but removing some sediments and some, rooted plants isn't really making a dent in the phosphorus.
But also putting phosphorus into an emerging wetland, it actually is going to sequester more phosphorus because you're going to get plant and you get a wetland growth in there. So I'm not sure.
Yeah.
You may have a net, maybe a net improvement. So you're not just moving it around, Christine. You're changing the form, and to Delia's point, maybe that's a benefit. I think we should keep that as an open issue. I don't, maybe there are too many variables for us to kind of wrap our heads around, but I think, the more we dredge and the more we improve the health of the pond and the open water, the better off we're going to be.
Mm.
But I
If
think,
you can get it deep enough, regardless of the phosphorus, I mean, you're not going to get you're not going to get the milfoil fanwort bloom, densities because the water's going to be too deep. My understanding is milfoil doesn't really grow in water that's deeper than 7 feet.
Mhm.
Just doesn't have the sunlight it needs, regardless of phosphorus. So,
Right.
So I think the focus should just be on increasing the depth, and that solves a lot of the issues associated with phosphorus, but not really necessarily worrying about them.
And there's the thing about the cost and quantity. I mean, I think that's because is it cost restrictive? Is it because we're trying to get to a depth? We need to figure out what that depth is and then how much area we can do sort of within the financial restrictions of that as well, based on that. So I think it still comes back to the numbers that we're always trying to get to for our final proposal.
Well, we can
Because
back out. Yeah, we can back out the total volume, but that doesn't it's not really linked necessarily to the depth right now.
Right.
We can get the same volume, different depths and areas.
Right, depending on the areas, but it's like you could almost reduce the size of the depth if you're hitting the areas, not reduce the size of the depth, reduce the size of the areas if you're getting to the areas that have the most invasives.
Right. Yeah, agreed.
I mean, so whether it's, part, well, it's going to be part in pond and out of pond disposal regardless. So I think getting the cost estimates, for the 14,000 in pond and the remainder outside is a good start. We could always modify it, and that would bring down the cost. If later on we wanted to look at in pond disposal, we could look at that separately, Delia, and kind of get the whole task force to
Right.
look at.
I'm thinking about that as you're saying that, and we don't really have. That's a. So what? When we ask a contractor to give us a cost, we have the existing design for the dredging. And we've talked about maybe that can be modified, and that's a separate conversation. But we're going to give them a plan that shows the existing dredge locations.
Right.
And then we say, we want to put it in this field over here. And so they can say, they understand where that is going to be, they can cost, what's the, length of pipe that they need to do the dewatering or to do the dredging to get it to that field, and then length of pipe to get the dewatering back. Here's the field, what's the approximate linear footage of their erosion controls that they need. So they can develop really conceptual cost estimates. But if we're now going to ask them, oh, and we want a cost to understand disposal of in-pond sediments, and we just say, tell us what that's going to be. They don't have any data we don't have any information to give them to make a decision. So we're going to say,
I'm confused. The 14,000, is that in the original plan? 14,000 in pond?
no, that was in the alternatives analysis.
That wasn't in the okay.
So
right.
so what's in the RFP is 5,000 yards to create the 1 acre wetland shelf. So that's there, and that will be part of what we're asking, but it's just that design of that 5,000 yards, because we have plans for that. you know, it's really, I think it's challenging for us to ask. You know, I can think about this and we can all think about this and figure out if there's a way that it makes sense to be able to provide a contractor with enough information that already what we're asking is pretty conceptual. But I think if we ask them, give us an in-pond placement, we just don't have enough information
Yeah,
that
no,
we're
I
gonna
think
get
you're right.
a number back.
I think you go with what was in the RFP, you just change the disposal area. And then if the costs are reasonable, then we can start from there. I mean,
Yes, exactly.
yeah,
And we'll ask, you know, give us a separate cost as was done in the bid. What is it to dispose of it off-site versus what is it to create the wetland shelf? Because those are different costs. And if we want to, I wouldn't think this is something we want to do, but you might extrapolate from those in-pond creation costs, what your, you know,
but
you did
Delia,
1
right now,
acre versus 10 acres.
I would keep it as simple as possible right now.
Yep, I would too.
Take the plan we have, it has 5,000 to create the shelf, the rest are going off-site, and just ask for 3 amounts going off-site.
Yep.
And then, so the only change is.
Okay,
how much-
that's, I
Yeah.
think that's right. I think what I was understanding, and I'm sorry if I freaked out because I was confused, but what I understood was that we were going to also ask for the 14,000 to 25,000 for in-pond movement of
No.
sediment.
I
I'm
don't think
sorry
so.
to,
I think
I'm
we were
sorry to
good.
take us down that rabbit hole, but that's,
Okay.
I think
Yep.
that's a future rabbit hole to go down.
Good. Okay,
So should we go through this then?
I'm gonna head, guys, because I have to get out.
Okay.
I will.
oh,
Yeah.
thanks, Bruce.
All right,
I'll
Bruce, we'll
see you
talk to you
tomorrow night.
Okay,
Christine, I have to get off in about 5 minutes also, so,
so then I guess we won't get really into it.
yeah, I'm sorry, yeah,
I'll put this on Google Drive. Maybe we'll be better prepared to kind of go over it as a group, looking at the same document next time or tomorrow even.
Tomorrow night, actually.
you guys do it tomorrow, it's,
Yeah,
that's fine.
I did have one thing to look at with the EA map you sent today, Delia. Is
Yeah.
that something we can squeeze in here?
Of course, I can, yep.
Let me see. I could probably share my screen. Yeah, I might try that because I have it here. That's not letting me. I don't know why it's not letting. It's all it says is an error. Shoot.
Okay, look, I can,
Basically, I'm still kind of stuck on.
let me just pull it up. Give me 1 second.
I don't know why it's not letting me.
Which one?
So the depths.
So do you want, what, there was a figure 2 and a figure 4. Do you want the figure 4? Field capacity?
Yeah, I don't. Let me see. Do I have? Yeah, I have it. No, I can't close the share window. Okay, there it goes. Yeah, figure 4.
Okay. So I think I have to close this. I'm having trouble too. Give me 1 second. All right.
Weird.
So one of them, there it goes. One of them is a big file and this one, okay. Going between the two. Should be able to see this in just a
Yeah.
sec.
Okay, good. Yeah, so the southeast corner of that field, I went in and looked at the LiDAR data that they are accessing. And so there's a discrepancy, like the contours are correct, but what they're saying is the depth of fill just seems reversed on the east side. So in the southeast corner, the rail trail's at elevation 136 and it goes down to 129 in the flat of the field. So that's like a 7-foot difference.
Here,
Yep, compared to
Okay.
the rail trail. So to me, there's still a discrepancy. And then Route 2 is at elevation 132 in that northeast corner, and the flat part of the field is 128. So that's a 4-foot difference.
right.
So to me,
Um,
the deep It'll be in that southeast corner.
And I did ask them about that. I had a call with them last week. And you are welcome to join any of these calls. I know they're during the day and they might not be as easy for you. But so here's the contour map, and I think that aligns with what you were saying, where this is, you know, this is a 129, this is
Yeah.
a 128. So this is actually, this is a little bit, this is a little higher, this is a little, it's a foot off, right? But there's that. What,
Yeah, it should be able to hold more because the rail trail is so much higher than Route 2.
so she's preparing a technical memorandum to accompany this analysis. And I think that will help explain some of these questions.
Okay.
But particularly in this corner here, because there's a lot of tree roots in this area, there were some other considerations that she took into account that she did not want. She was very conservative in how much fill could be placed in this area, in all of the fields. So there's maybe more, maybe less capacity. This is very conceptual, 30%, as you know, Keith, you know, engineers are going to be very conservative when it's this level of, you know, early design. So I did raise your concerns with her, and she explained why she came up with what she came up with. She did review it. She didn't change what she felt was, you know, the analysis. She felt that she was still coming up with that 49,500. But
Okay.
I asked her, just prepare a technical memo, because I think it's better if she can explain it and have the task force understand it from that perspective. And I think
Yep.
if we want her to come and explain it at our next meeting, that we don't have, you know, obviously not tomorrow, but at a future meeting, then that would be useful. If that would be useful, we can certainly do that.
Yeah, I mean, I'm open to just looking at a written analysis, but I guess just to also have her look at just, you know, looks like you might have 4-foot elevation difference by Route 2, and so that depth of fill is pushing up to 7.5 feet. Like, I just don't understand how she got that. So
I know, and she explained it to me, and it's a reverse of what, because of the way CAD works, and I didn't understand. It was, and she was explaining it as we were talking, and it was not clear to me. So I said, if you could just put that into a memo,
okay,
so that we can review it and then, you know, ask questions. I think
if we're able
Yeah.
to go that route, I appreciate it.
I have a dumb question for tonight. So back to that map, what limits us to how much soil we can excavate? I understand the contours and the fill, but we're not limited by that. We can,
No, it's not a dumb question. You know, I mean, this was really just the first pass. Does the field even have capacity for, you know, that 33,000 yards or 30,000 yards?
That
I mean,
map,
if bedrock and groundwater permit, I mean, and DOC permit, you can take 10 feet of, 15 feet of fill out of there, right? Yeah.
but the
Effectively, that's
initial
the minimum. Sorry,
sorry, go
go
ahead.
ahead.
I was just going to clarify that initial 49,000 cubic yard holding capacity of the field, you know, currently is based off of that map we were just looking at. So I just want to make sure our starting number is accurate. So, but I agree, we can go bigger than that potentially if we excavate the field, but that's like a secondary, you know, next step analysis.
So that 49,000 the capacity without excavation?
Yeah.
Mhm.
Wow.
I will say that, you know, we talked about the 6 inches of topsoil that Jeff mentioned needs to come back. And this analysis does not account for that. But at the end of the day, it doesn't matter, because you just go down 6 more inches,
Right.
you know, so it
So-
doesn't
so-
matter.
When we told Bruce 49,000 cubic yards, that's not fill that's being removed.
It
No,
could be,
Yeah, we could, yeah, that. So if the capacity is 49.5 right now with existing contours, and we excavated 50,000 more, we could put 100,000. I know, forgetting for the moment that we need topping on the dredge, we could put a lot more than 49,000 there if we excavate.
right,
If
but let's not, that's correct, but let's not forget that,
if StarMet paid for the excavation,
yep.
we
But
could put a
let's
lot.
not forget that 49,000 yards of just without even excavation of anything beyond the topsoil, that doesn't account for access, you know, so where your trucks are going to go to dump. It doesn't account for erosion controls that have to be placed around the entire site. It doesn't account for your infrastructure to get your piping in and out,
yeah,
all
I
that.
understand.
So it's not 49,000 yards, it is something below that. That
Okay.
49,000 is just the volume for the
But
field.
that's
Okay.
not without giving Bruce 1 cubic yard. There's no excavation on the plan. Okay.
Beyond the topsoil.
Huh. Okay. So a lot
The
more.
topsoil, and because Jeff wants that for the prison.
Right. But there's a lot more capacity. I wouldn't say it's unlimited, but don't we have to figure out what the capacity is with excavation? Since now we have a cost, we can defer the cost of excavation?
I think, yeah, I think that's right, but I think first we need to know if the dredging cost
Yeah.
is a feasible cost, and if it
Yeah.
is, so that's our if this, then that needs to be part of the proposal.
Okay, so it's not fantasy land when we tell the RFI, give us 100,000 cubic yards. That field could accommodate that theoretically.
Yeah, I think we just need to hit those
Maybe.
volumes and we can figure out a way to make it work.
Yeah.
The
Okay.
cost for us,
Right.
the town to pay the dredge 100,000 cubic yards, assuming it will go in that field.
That's right.
Okay. Okay, with that, I have to get off, but that was a very good piece of knowledge that I didn't have in my head, and thanks for sharing it.
I'll see, we'll try to get it incorporated into the proposal.
Okay.
Right. And if you have
Yeah.
anything you want to add for us to look at tomorrow night, please do so.
Yeah,
Okay.
If you come up with anything else.
Yeah.
Have a good meeting. See you guys.
Thanks, Paul, see you.
All right, thank you, everyone. Goodbye.
We're good.
Is that
huh?
it?
Oh,
We're good.
we didn't ask for
The meeting.
public comments, and I didn't close the meeting.
Yeah.
Are there any public comments? Okay. All right, so the meeting is officially closed at 7:18.